Today we're on pages 166 and 167 of our textbook, starting a new unit, Unit 6, which is quadratic functions and their algebra. Our first lesson is on factoring. You had a lot of practice in Algebra 1, but yes, it was 2 years ago. So, recall, to factor something has two meanings. As a verb, it is to rewrite a quantity as an equivalent product. Like if you were asked to factor 16, it's equal to 2 times 8, or 4 times 4, or 1 times 16. Factor as a noun is an individual component of a product. So the factors of 16, 1 times 16, 2 times 8, and 4 times 4. So you have 5 factors of 16. Always keep in mind that when we factor a quantity, we are rewriting it in a different form that is equal to the original quantity. Exercise number 1, rewrite each of the following binomials, 2 terms, we will review, as a product of an integer and a binomial. Looking at 5x plus 10, we want to rewrite it as the product of an integer and a binomial. So we look at 5x and 10. What do they have in common? What's a common factor? Well, 5 is a common factor. If we factor out 5 times what will give us 5x? And then 5 times what will give us positive 10, positive 2. So 5x plus 10 factors into 5 times x plus 2, 5 being the integer, x plus 2 the binomial. What's a common factor to 2x and 6? It is 2. 2 times x minus 3 would result in 2x minus 6. What's a common factor of 6 and negative 14x? 2 is common. Factor out 2. And 3 minus 7x is our binomial factor. The above type of factoring is called factoring out the greatest common factor, GCF. You've seen that before, heard that before. The greatest common factor can be numbers, variables, or both. Write each of the following binomials as a product of a binomial's GCF and another binomial. 3x squared plus 6x, what is common to both of these terms is 3x. That's the greatest common factor. Factor out 3x. 3x times x would result in 3x squared, and 3x times positive 2 would result in positive 6x. Taking out the greatest common factor to these two terms, to 20 and 5 is 5, and to x and x squared is x. So 5x is factored out, and the other factor is 4 minus x. 30x squared, negative 20. Both have 10 as a common factor. 3x squared minus 2. Exercise 3, rewrite each of the following trinomials as a product of its GCF and another trinomial. So we have 3 terms. What's common to all 3 is 2. Factor out 2 from each term. We get x squared plus 4x plus 5. B, what's common to all 3 of these terms? 5. I'll write it below. 5 times 2x squared would result in 10x squared. 5 times negative 4x would give us negative 20x, and then 5 times 1 would result in 5. Greatest common factor to 8x cubed, negative 12x squared, and positive 20x. Well, to the coefficients, they all have a factor of 4, and to the variable x cubed, x squared, x, they all have an x. So 4x and our trinomial would be 2x squared minus 3x plus 5. The conjugate of a binomial is identical to it, but with the opposite sign in the middle. Example, to consider the binomial x plus 5. This binomial has a conjugate, just the opposite sign. Instead of a plus, minus. So this conjugate is x minus 5. The conjugate multiplication pattern. If you have the product of a binomial and its conjugate, the result is the first term squared, subtract the second term squared. So in other words, if we have x minus a and its conjugate, x plus a, their product would equal x squared minus a squared. The binomial x plus 7, its conjugate is x minus 7. The product would be x squared minus 7 squared, which is simply x squared minus 49. The binomial 8 plus x, its conjugate is 8 minus x. The product would be 8 squared minus x squared, which is the same as 64 minus x squared. If a binomial is the special form, x squared minus a squared, known as the difference of perfect squares, you've heard this before in Algebra 1, then it factors into x plus a times x minus a. So you have to know difference of perfect squares. This is not new to you. You've worked with this before. Exercise number 4, write each of the following binomials as the product of a conjugate pair. Okay, so in other words, we have x squared minus 9, which is the same as x squared minus 3 squared. So this factors into the binomial x plus 3 times x minus 3, right? The conjugate pair, x plus 3, x minus 3. Take this binomial. 4x to the 8th is the same as 2x to the 4th squared minus 49y to the 16th can be written as 7y to the 8th squared. Right? Because a power to a power, you would multiply. 4 times 2 is 8, 8 times 2 is 16. Okay, so now that it's written as something squared minus something else squared, then it factors into this conjugate pair. This is a different color. So it's going to be 2x to the 4th plus 7y to the 8th times 2x to the 4th minus 7y to the 8th. Four x squared minus 25. That's 2x squared minus 5 squared. So the conjugate pair, 2x minus 5 and 2x plus 5. Just go back and circle. So this is our answer here. It's a product of the conjugate pair. And D. 16 is 4 squared, 81x squared is 9x squared. 4 plus 9x times 4 minus 9x. And it doesn't matter whether you have the plus binomial first and then followed by the subtraction or vice versa. Okay, same for number 5. We want to express the binomial as the product of conjugate pair, and remember this only works if it is difference. It has to be subtraction. It does not work if it's addition. So we have x plus a half, x minus a half. (36a to the 6th), that would be 6a to the 3rd squared, minus now b to the 100, that is b to the 50th squared, and 100 would be 10 squared. The conjugate pair, 6a to the 3rd plus b to the 50th over 10 times 6a to the 3rd minus b to the 50th over 10. C, I'm going to skip the middle step. This is going to be 2/9 x plus 7/3 and 2/9 x minus 7/3. And D, 6x times 6x, so 6x plus 7y times 6x minus 7y. Again, difference factoring the difference of perfect squares. It's not new to you. You've had practice with that in Algebra 1. Factoring an expression until it cannot be factored anymore is known as complete factoring. In general, when completely factoring an expression, the first type of factoring you always consider is factoring out a GCF. So you always look, is there something common to your terms? If there is, take that out first. Using a combination of GCF and difference of perfect squares, write each of the following in its completely factored form. Okay, so A, these two terms have a 5 in common. We take out 5 and then we end up with x squared minus 4. Now this binomial is the difference of perfect squares. So that factors into x plus 2 times x minus 2. Bring down your GCF of 5. And now this is completely factored. B, take out the GCF 7, 4x squared minus 1. This is a binomial. It is the difference of perfect squares, so that factors further into 2x plus 1 times 2x minus 1. And again, don't forget to bring down the greatest common factor. C, I believe 10, yeah, 10 is common to 40 and 250. And now the 4 minus 25x squared is the difference of perfect squares. 2 plus 5x times 2 minus 5x. And D, what's common to both of these terms is a 3x, x squared minus 16, and x squared minus 16 is the difference of perfect squares. That factors into x plus 4 times x minus 4. Okay. So everything we've done up until this point is you've seen before. You've practiced in Algebra 1. This is new. Sum and difference of perfect cubes. So just as there's a pattern for factoring the difference of perfect squares, there's a formula or pattern for factoring the sum and difference of perfect cubes. So let's first recall our perfect cubes. 1, 8, 27, 64, 125. Right? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. The sum of perfect cubes, if we have a cubed plus b cubed, it's going to factor into the product of a binomial, right? This is a binomial, and trinomial. So just like you know how to factor the difference of perfect squares because you kind of memorize this, right? It's backwards. If you have x squared minus a squared, then that factors into x minus a times x plus a. Well, we've got to memorize this for sum or difference of cubes. The same with the difference. If you have a cubed minus b cubed, it's going to factor into the binomial a minus b, and then the trinomial a squared plus ab plus b squared. Now, we look at the signs here, all right? The sign here, for sum, we had positive or plus for our binomial, and then minus, and then plus for our trinomial. So this SOAP stands for the signs go same, O is for opposite, A is for always, and P is for plus, or positive. So SOAP, same, opposite, always, plus. All right. If it's sum, binomial has the same sign. Trinomial, first sign is opposite, minus, and then always plus. If we start off with the difference of perfect cubes, binomial has the same sign, subtraction, and then opposite, always plus. So factor each of the following expressions. So x cubed plus 8, x cubed plus 2 cubed. So x is our a, 2 is our b. So this is going to be the binomial. And then trinomial. So I always start with the binomial parentheses and then the trinomial parentheses. I could do the signs first if I want. Same, opposite, always, plus. So same would be addition, opposite, subtraction, always, plus. Now the binomial is simply your x plus 2. And the trinomial is going to be a is x, and b is 2. So we want x squared minus their product, right? A times b, so x times 2, which is 2x, plus b squared. 2 squared is 4. Done. B. This is 1 cubed plus 4x cubed. This is going to factor into the binomial and then the trinomial. Binomial is the easiest. Basically, you're just copying this 1 plus 4x. The trinomial, you're taking 1 and you're squaring it, which is 1, minus, right? So same, opposite, always, plus. So 1 minus the product. 1 times 4x is 4x, and then 4x squared, which would be written like this, but we want it in its simplified form. So 1 plus 4x times 1 minus 4x plus 4x squared is 16x squared. This is our answer. For C, we have subtraction. We have the difference of perfect cubes. This is x cubed minus 1000 is equivalent to 10 cubed. So this is going to equal the binomial times the trinomial. Do your signs. Same, opposite, always plus. X minus 10 is the binomial. Trinomial, the first term is going to be x squared. And then the middle term is the product, x times 10. And then the end is 10 squared, 100. D, this is xy cubed minus 5 cubed. Binomial and then trinomial. For signs, same, opposite, always plus. Xy minus 5 is the binomial. Trinomial, you're going to take xy and times it by xy and get x squared y squared. The middle term of the trinomial is the product xy times 5, 5xy. And the last term of the trinomial is 5 squared, which is 25. You're welcome to pause the video and try the others on your own if you like. There's no GCF here. This is the cube 3x cubed plus 2y cubed. And we have the binomial and then the trinomial. 3x plus 2y, the signs go same, opposite, always plus. 3x times 3x, 9x squared. If you want, do the last, or the first and the last of the trinomial. 2y times 2y, 4y squared. And then the middle is just their product. 3x times 2y is 6xy. Simple. F, nothing common there. This is 2x cubed minus 5y cubed. So binomial times the trinomial. So same, opposite, always plus. 2x minus 5y is the binomial. 2x times 2x is 4x squared. If I want to jump to the last term of the trinomial, it's 5y times 5y, which is 25y squared. And then the middle term of the trinomial, is their product. 2x times 5y is 10xy. Oh, 250 and 2 and the x's. There's a GCF here. That needs to come out. Right. GCF of 2x. So this is 2x times 125 x cubed minus 1, which is 5x cubed minus 1 cubed. So this is going to factor, this is a difference of perfect cubes. It factors into the binomial times the trinomial. Binomial is 5x minus 1. Trinomial 5x times 5x is 25x squared. Signs go same, opposite, always plus. 5x times 1 is 5x, that's the middle term, and 1 times 1 is the last term of the trinomial. Bring down the GCF of 2x, and there's the complete factorization. And the last one here, 3x squared is common. We get x to the third minus 8. And now x to the third minus 8 is the difference of perfect cubes. So this factors into the binomial x minus 2 and the trinomial x times x is x squared to start. At the end, 2 times 2 is 4. Signs go same, opposite, always plus. And the middle term of the trinomial is the product x times 2. Bring down the GCF of 3x squared. And there's the complete factorization. Thank you very much for your attention.